Next, we're going to want to find the composite function g of f of x. So instead of last time where we found f of g of x, this time it's going to be g of f of x. And here, this time we want to have every x term in the g of x function become the entire f of x function. So this function would look a little bit like, we have an x term in the numerator of g of x, so I'm going to put the entire f of x function in place of this x term. X minus 5 over x plus 8, and then plus 4 separately, over, you have another x term on the denominator, so I want the entire f function again. This time we have minus 7 separately. And now, just like last time, we're going to simplify this complex fraction. Now once again, let's start with the numerator. Write it out separately, so it's easier to look at, work with. X minus 5 over x plus 8, plus 4. And to do this operation, we want to have plus 4 being a fraction of denominator x plus 8. So x minus 5 again, plus 4 multiplied by x plus 8, and over x plus 8. Expand out the brackets. 4 times x is 4x. 4 times 8 is 32. Over x plus 8 again. Now we combine like terms. X plus 4x, 5x, minus 5 plus 32, plus 27, and over x plus 8. And now that we've simplified our numerator, we're going to do exact same thing, but this time the denominator. So let's rewrite that out. X minus 5 over x plus 8 and minus 7 separately. Again, we want minus 7 to be a common denominator, so we're going to have x plus 5 minus 7 multiplied by x plus 8 over x plus 8. Multiply out the brackets. Minus 7 times x, minus 7x, minus 7 and 8, minus 56, over x plus 8. Then we combine like terms. X minus 7x, minus 6x, minus 5, minus 56, minus 61, over x plus 8. So now that we've simplified our numerator and denominator, let's rewrite this complex fraction with what we know. We have 5x plus 27 over x plus 8, and all over minus 6x minus 61 over x plus 8. Now once again, we're going to divide these two fractions by each other. Easiest way to do that is to multiply the top fraction by the inverse of the bottom fraction. And that's going to leave us with 5x plus 27 over minus 6x minus 61. Because once again, the x plus 8s will cancel out. Now we figured out that our g of f function is 5x plus 27 over minus 6x minus 61. But we've still got to find the domain of this composite function. So just like last time, the domain of this composite function is going to include all the values of x that are defined for this composite function and also the f of x function. And once again, since we've got two division symbols, we're looking to avoid division by 0. So for this composite function, I'm going to exclude values where minus 6x minus 61 is equal to 0. Therefore, minus 6x is 61. We move the 61 to the right side. And then we divide by minus 6. So that's going to be minus 61 over 6. So I want to exclude this value from my domain. But I also want to exclude the values of x where x plus 8 will equal to 0. So we've got x plus 8 equals 0, so therefore x is minus 8. We want to exclude this value as well. So therefore, for this function g of f, the domain is going to start with x is all real numbers, and then we're going to exclude x is equal to minus 8 and minus 61 over 6. And this is going to be the domain of your g of f function. So to finally recap on what our final answers are going to be, our f of g function is minus 4x plus 39 over 9x minus 52. And the domain of this function is going to be x is all real numbers excluding plus 7 and plus 52 over 9. Our g of f function is going to be 5x plus 27 over minus 6x minus 61. The domain of this function is going to be x is all real numbers excluding x is minus 8 and minus 61 over 6. This is your final answer. Hopefully you found my guidance for today's question useful, and if you have any of your own questions, leave them in the comments and I will get to them. See you next time.